Hello, this is my English speaking practice and I'm working on the code. And right now I'm solving the dynamic programming problems, because it's my challenge. I want to solve the problems quickly. So let's try. Largest divisible subset. It seems difficult. Given a set of distinct positive integers nums, return the largest subset answer such that every pair answer I and answer j of elements in this subset satisfies the answer at I should be divisible. The answer at I divisible is divisible answer at j, or answer at j divisible answer at I. If there are multiple solutions, return any of them. Okay. The example 1, if we get the 1, 2, 3, the output is 1, 2, and 1, 3 is also accepted because the 2 is divisible by 1 and 3 is also divisible by 1. Okay. If I get okay, if I get 1, 2, 4, and 8, the answer is 1, 2, 4, and 8 because it's a largest subset. 8 is divisible by I and j is every pair. Okay, so it means 8 is divisible by 4, 2, and 1. So 8 is good. 4 is divisible by 2 and 1. 2 is divisible by 1. We don't need to check the 4 is divisible 8 because we already checked 8 is divisible by 4. So we check this condition. So we don't have to care about so we should always check the number from the larger one. Larger one should be divisible by the smaller one. Okay. That's a problem. Okay, so let's create our file. And define the what is divisible, largest divisible subset. Importing list type, and we take the nums. That is a list of integers. And let me see the constraints. The length of numbers is 1000 at the most, and the value of numbers is large. It's 2 times 10 power of 9. Too big. And all the integers in nums are unique. Okay, I got it. Okay. Yeah, when I handle this kinds of problem, I will ask to myself, do mm, do we have to generate all possible combinations? Yes or not? In this case, all possible combinations means yeah, or subsets, or subsets. So in this case, um, yeah, we pick the 8 and we check all remaining elements. And in this case, yeah, we pick 8 and the remaining part would be 1, 2, and 4, and then we pick 4, yeah, and we check the 1, 2. Okay, yeah, it's a yeah. So yeah, this is a naive approach. This is a naive approach. So yeah, of course I can solve this problem by this approach, because we check every pairs. We check every pairs, and yeah, if it meets conditions, we return it. It's a largest subset. Yeah, but I think yeah, I think there must be a substructure problems. There is a sub problems. Yeah, we can define the sub problem, cause divisible. Yeah, divisible uh, means yeah. Let's think about this case. The 8 is divisible by 4, and 4 is divisible by 2, and yeah, and do we have to check 8 check if 8 is divisible by 2? No, we don't have to, because if yeah, if it's divisible, uh, if if 8 is divisible by 4 and 8 4 is divisible by 2, 8 must be divisible by 2, so we don't have to check all combinations, right? So there is a sub problems. We can define the sub problems. So how do I define sub problems, and how do I implement the solutions? Okay, I think yeah, first of all, we should sort it. Yeah, we should sort it. Okay, 1, 2, and 4, and 8, and we have to find the largest subset. Subset means yeah, we choose elements from them. Yeah, and every pairs in the subset must satisfy this condition. Yeah, and okay, okay, got it. Yeah, yeah. And so we have to define the subproblems and what kinds of subproblems. Okay, that there are two types of subproblems. Yeah, right. It's an independent subproblem or dependent subproblems. Independent subproblems means subproblems. They are independent from others. So we can use the divide and conquer approach. But this problem seems be dependent to other subproblems, because if we look at 1 and 2, it 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 affects when it affects the case when we when we solve these problems, because yeah, we I feel like we can use these sub problems when we solve these problems. Okay, so yeah, the sub problems is dependent, right? Okay, so when we solve the dependent problems, we use dynamic programming, right? Yeah, and dynamic programming, to solve the dynamic programming, to implement the dynamic programming, we have two options. Yeah, bottom up solutions or top down solutions. But yeah, I feel like bottom up solutions would be nice this case, because yeah, we solve these problems, and it has one and two, but the largest divide lowest, sorry, so in this case, we check, let's assume we already solved this problem, 1 and 2. The 2 is divisible by 1, so we can use this subset 1 and 2. And yeah, when we solve this problem for 4, we check 2. We just check for 2, right? If we can divide 4 by 2, we can divide 4 by 1, because 2 is divisible by 1. Okay, but we don't have to about 1. Okay, so we can update the subset for 1 to 4. Okay. So for example, 1 to 4, and let's think about 1 to 5. Okay, and for this, we just, yeah, obviously we have one element. Oh, that's not meet condition. It doesn't meet condition, because the condition requires pairs. So it starts with 2 elements at least. Okay, and let's look at 4. Then the valid subset is like this, and the most the largest element must be divisible by other elements in the subset. So we just check the largest element. Okay, so we can, and 4 is divisible by 2, so we can update the subset like this. And for this case, the 5 is not divisible by 2, so we cannot update this. But instead we use this. We can create a new subset like this. So for example, we should update both elements like this. And when we look at 15, it's not good. But this could be, and for example, the next element is 45. This only this array can be updated, okay, because it's divisible by 15. So we cannot choose the locally optimal options, because we don't know what is the best options at this point, okay. So for each element we have to think about the possible cases, okay. So how to implement this? Let's see the size. 1000. Okay, 1000. Hmm. 1000. So we check the all of elements in the num arrays. So it's a linear process, and for each loop we should have to check the largest number and its size. The size is important because it's the no, we have to return the subset itself, so we have to store the array. We cannot omit this, okay. So the basically oh, how about this? When we choose 10, the 10 would be used for checking later. How about 2 and 5? That's not that's not important because it's included in 10. So if it is the same size, we don't care about. The important thing is the last element and its size, okay. So that's the logic to determine the information. So let's define the DPI. What is it for? DPI means the largest subset at this point. Largest subset at this point? No, because the last number would be changed at this point, okay, because they are all 3, length is 3, but the last element is 10, 10 and 15, and we don't know which is better at this point, because if the next number is if the 45 comes next, 15 is better because we can update the subset. We can append the 45 to the array. But sometimes let's think about like this. 45 and 100 and 200. This yeah, so in this case, since 100 is not divisible by 15, so we cannot update this array. Yeah, this array is, yeah, this array is updated like this at this point, but yeah, it's finished. It's finished for this because it's the last element is 10. We can update for, yeah, the 100 when the 100 comes in and 200 comes in, because it's divisible by 10. So the largest subset is like 1, 2, 10, 100 and 200, or 1, 5, 10, 100 and 200. Okay, so DPI should have the largest subset whose last element is nums ith, right? So for this, so I is 0, 1, 2, 3. So I is 3, 10 should be the last element. Okay, and we have two options, but we don't care about the element. Yeah, we choose the longer one, and the last element should be 10. That's it. That's a condition. And when we when we update dp4, the number is 15, so it should be 15, right? So in this case, 10 is not good. 5 is good. But how can we find the previous state? It can be divisible. This is a little bit difficult. Okay, so we should loop linearly, so it be, yeah, double loop. But yeah, the length of numbers is not too large, so we can do it. So we initialize the dp arrays, for in range len num. This is this subset, and dp0 is dp nums 0. No, dp0 is the because dp1, yeah, because the subset should be subset should have two elements at least, and they are divisible. So the DPI DPI would be nums 0 and nums I if nums 1 divisible nums 0, else we return empty. That's an empty subset, right? Okay, DPI is like this. DP0 is, yeah, empty. I think so. Okay, here is a base case, and we are going to do a bottom-up solutions. Yep. For I in range, we start with 2 and length nums and I and for num, for subset in DP, yeah, I minus 1, no, I until I, okay, and last element is subset if it's empty, continue, we do nothing. If it has pairs, at least one pair at least, we can get last element. It's the largest element. So we can check the nums I can be divided last element. If it is, that means we can update so we can update, so copy the subset and append the nums I, okay, and DPI is like this. Oh, wait. If len ARR length of DPI is less than the new array, we can update it. Yeah. Okay. Yeah, that makes sense. And yeah, this is 1000 at most, and also this is 1000 at most, so it's okay. That's it. I think that's it. Let me run. Wrong answer. Really? Really? Oh, this is correct. 1 2 3 1 2 3. I see. I don't know where we cannot know where it's the largest subset, so we have to for subset in DP, and if then result greater than len subset, we update the result and subset and return result, right? Yeah, let me submit it. Index out of range. What? I and J could be the same, so I misunderstood. Yeah, but the remaining part won't change, right? I think so. Wrong answer. 3 and 3 and 17. Okay, right. I see. Like this. Okay? Because, yeah. Ah, no, 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 no. I know. Num0, cause we can use num0, and if it's divisible, we can add two elements, and if it cannot be divisible, we just use the number at the 1, because that's the definition. Okay, yeah, so really 3 4 3 4 3 4 this is not good. If the subset is if empty subset, yeah, really nine. Okay, let's see the subsets here. Two, 2, 4, 2, 6. Okay, we couldn't append a 9. If we didn't append the element at all, yeah, we should update. Yeah, if this means we didn't update the DPI from the existing subset, right? So this case we just initialize the number itself. So it is nums DPI should be nums like this. Yeah. correct. Great. Great, great, great. Okay. So let's review. Yeah, we handle edge cases here, and I misunderstood about the condition. Yeah, this is obvious, and about this, I thought I and j should be different, but it's not true. Yeah, I and j could be same. So yeah, the only one element in the subset is allowed. Okay, so if the length of numbers is 1, the answer would be like this. And then to make it easy to handle, we sort the original numbers, and this problem can be solved by defining to solve subproblems, and we define the subproblems like this. And DPI should have the largest subset whose last element is nums I. So here is the example. The original number array is 1, 2, 5, 10, 15, 14, 100, 200, and we are going to check one by one. And for the first and the second element, we update them as a base case. This is obvious because when we use the first number, the subset is empty, so we can append the first element like this. And regarding for the second we should check the condition. If they are divisible, we can append both of them. If it's not, we just append only the second element, right? But here is the base case, and then we are going to update the ith number like this. So we start with 2 and up to length of numbers. Yeah, and we have to take a look at the previous subset like this. So for example, when we want to append 45, we should have all of the previous subsets. So it's like 1 and 1 and 2 and 1 and 5. And for regarding 10, we might have two options, but it must be one of them. But we don't care about it. Because the important thing is the last element and its size. And size is the same, and the last element is same. Yeah. In my implementation, if the length is greater than the existing one, we can update. So the first one is used in my implementation. Okay, so it's the DP10 is like this, and for 15 is like this. And when we want to update the 45, we look at 1, 2, but 2 is not met, and 5 is good, 10 is not good, 15 is good, and 15 is the most most yeah, largest and longest subset. So we append 45 to this array. So the array is like this. This is how we solve the sub problems. Okay, so we going up to the end of the numbers, and finally we return it. But the definition is like this. So the last element of dp is not always the answer, so we have to check the largest subset, over dp, and return it. That's it. Okay. This is good. I want to solve 2 more problems. Guess number higher or lower. We are playing the guessing game. The game will work as follows. I pick a number between 1 and n. You guess a number. If you guess its right number, you win the game. If you guess the wrong number, then I will tell you whether the number I picked is higher or lower, and you will continue guessing. Every time you guess a wrong number x, you will pay $X. If you run out of money, you lose the game. Given a particular n, return the minimum amount of money. You need to guarantee a win regardless of what number I pick. Feels like difficult. N is 10. N is 10. The winning strategy is as follows. The range is 1 to 10. Guess 7. If this is my number, your total is $0. If my number is higher, the range is 8 to 10. Guess 9. It feels like so difficult. I need to understand this explanation. Why guess 7 at first? If this my number, your total is 0. Otherwise you play 7? Yeah? The possible number be 8, 9, 10. Guess 9. I see. I feel like I understand why the 7 is chosen at first. One, two, three, 4, 5, 6. Yes. 4, 5, 6. So guess 5. That's it. うんうんうんうんうん。Guess number higher and low. So in this case, the n is 200 at most. Okay, so we have to think about the worst case. So we have to think about when we get wrong. Okay, and at this time we have to pay the guest number. Okay, so guessing higher number is higher risk. Okay, so we want to reduce the number of guessing higher as much as possible. So so the first example, the first guess is 7 because if if it's if it's wrong, we can divide the problem like this. And for three numbers, we can get answer. We can get answer we paying for the middle number, because if it's correct, we don't have to pay any more, and if it's wrong, we can know the higher or lower, so we identify the number. So the important thing is to leave the three higher numbers when guessing. Okay, and for lower, that's the sub problems. We just solve these problems. Okay. So we can use recursive, and it takes one to n. Okay. If upper is 1, 1, 1. If upper is 2, for the worst case, guessing 1 and the answer is 2. So we pay for 1. And if upper is 3, 1, 2, 3, so we guess 2. And the worst case is 2. Here is a base case, and yeah, and 4, 3, 2, 4, 3, 2, and 1. So guessing 1. Yeah. Return rec upper -3, and the cost is upper -1. Is this correct? 1, 2, 3, 4. The worst case is guess 1 at first. The total cost is 4. Four is the 4 is the best. So I think this is good. Really? 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 Guess 7. We have to think about when we receive higher and lower, and we will choose the larger cost. Okay, so the cost is this at first. And if it's higher, we can guess. If it's lower, if it's lower, the upper is upper. Huh? What is it? Cost is upper. And lower. And we choose the larger one. Really? This is correct. I have no idea. okay, if we get a large number, we get wrong. We get wrong. So that is my understanding is not correct. Maybe we can use this structure. The triplet is the one element, and we choose one as it divides the as it generate two triplets. And also they have a structure like this. Pick one. If it's higher, we look at this and choose one. If it's lower, so how about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's why we choose 7 at first. Okay, the structure is like this. So the element is 7 plus 1. Fifteen times 2 plus 1, 31. 31 times plus 1, 60. Sixty-three times 2 plus 1, 127. That's the limit. So let's think about we divide it into 263s. Divide it to 231s, 215s, 27s, and 23s. And 2 1s. And we can identify. I think this is the optimal. This way we can achieve the ideal answer. So I'll code it. Cost is R minus 1 divided by 2 is a half, so upper minus half. This is a first guess. And higher. Lower. They are the higher. We want to, yeah, we can get guessing cost at this time, because at the time, because the half is half is 63. One, two, three, 4, 5. 1, 2, 3, 4, 5. Is it correct? Time limit exceeded. Why? Hmm. Ah, break. Hmm. I don't know why this is not good. 63 means 37 and 100 and 1. Okay, so for this part 31 and 31. So first we guess 37 and the answer is higher, 38 to 30, 69. Plus 31. Yeah, yeah, yeah. And 15. 15. 7, 7. So hmm. Ah. This is wrong. This is just times. How many times? We have to add these numbers. So like this. No, no, no. Higher. No. It's doesn't change. The initial cost would be 37. What is it? Upper cost is half. Initial cost is 69. Correct. One, two, three, four. B, the cost is 4. 1, 2, 3, 4. This is correct. 4, 8. 5 plus 4. This is correct. 12. Initial cost 20. Initial cost 13. Maybe this is wrong. This is wrong. This is wrong. What? higher. Huh? H. The initial cost is 69. The next cost would be, oh my gosh. $85 and $92. Oh, why? +1. Oh yeah, 19.3 is good. Higher is still greater than lower one. Oh really? How about 20? $20 should be 49. 20. $49. So So this is correct. How about 68? Okay, 68 is wrong. Mm, 68, 63, 5, 36, 37, 31. Yeah. Initial cost is 37. Mm, +15, 40, 50, 52, 53. Next cost is 53. Yeah. And +7, 61. 61, 61, 64, 65, 67. Hmm. Mm, 37. We shouldn't start with 37. We should start 53 maybe. But why? Sixty-eight. Let me see this for 68. Oh, it's really strong. Right. But I don't know the reason why this works. Yeah. I don't know why. Hmm? Mm. Okay, but I have no idea. So I gave up. Mm. There are a lot of solutions. Yeah, I will do it tomorrow. So, I will finish this stream. But this solution is mm, mm, I think this solution is good in terms of time complexity. The problem is how to find the first guess. didn't finish the stream. I will finish. See you.